Hello and welcome to our next lesson in this introduction to databases course. So in this first video, I want us to sort of understand why you're learning about joins. Okay, so um, in the last lesson, you learned how to um, create joins. In other words, how to write a query to get information from two tables, right? So why do we do that? Well, let's motivate let's motivate uh, the reason why. So let's assume that you are you have been asked by some school, right? Maybe a preschool, maybe a high school, to create a database, to design a database where they will keep track of the students and where they live. That's all they want. Which student lives where? So that if the student doesn't show up to school, then they can go and check on them. All right? So you're saying to yourself, that sounds easy enough. Let's look at the different scenarios, uh, how we can go about doing this. Okay, so this is the thing. We have this schema, right? So imagine that this is your table that you're creating. So when you want to describe it, our table, we do something like this. We put the name of the table, okay, and in parentheses, the name of the columns, okay, all right. This is not PostgreSQL code, okay. It's just me writing to explain to you. So if I were to imagine this schema, let's call this a schema. Okay. If I were to take this schema and sort of represent it as a table, it might look something like this, right? ID 1, Jane Smith, and number 3 Apple Street. No problem. And so you might say, this is easy, right? But when you're designing a database, you will be faced with new requirements and new challenges. And so what happens if, right, and I have it here, what happens if Jane has two addresses, okay? Let's say mother and father get a divorce and Jane lives between number 3 Apple Street and sometimes lives on um, Bird Avenue or Jump Street. All right. The point is, Jane now has multiple addresses, but you need to record that. So how do we do that? This schema doesn't work because this schema is only asking for one address, right? Remember, every column should have one piece of information. All right. One piece of information, one piece of information, one piece of information. Okay. So what do you do? Well, first option, we could change our schema. And so we'll say, all right, I know what to do. Instead of having ID, first name, last name, and one address, I'm going to have address 1 and I'm going to have address 2. That will do the trick. So now, all right, you have taken care of Jane. You can easily deal with Jane's row. Address 1, address 2. Now Jim only has one address. So his address 2 is blank. Right away, this should be sort of a little problem like, even if it's an empty space, uh, it's still space that is being wasted. Okay, but anyway, we have solved our problem. No problem, we've solved it. We can go home and celebrate. right? Now, you have a new student named Pearl. And it turns out that Pearl comes from a wealthy family, and Pearl lives or has his parents or her parents have 5 houses. One in Kaya district, one in Belize, one in Stan Creek, and on. So now the principal tells you, well, what are you going to do? We need to have Pearl in the database. What do we do? All right, so you see the problem, right? You can't just keep extending the schema. Or the schema is not good enough. Let's add another address column. Let's add a fourth address column. Let's add a fifth address column, right? That's not very scalable. And notice if it's only Pearl who has 5 addresses, then everybody who has only one address, you will have 4 wasted spaces. And remember, those spaces, they are bytes, right? They do take up space on your hard drive. So you're going to have a database with rows that have many empty columns, but it will still be counted, and so you will run out of space soon, right? Because those empty rows, still take bytes. All right. Okay, so our first option is not very flexible. All right. So most people would say, you know what? Let's just do that. Doesn't matter if we waste space. All right. So, but that's not the best approach. Okay. So in this course, we're supposed to learn best practices. All right. So that's the scenario. If the new student has 3 or 4 or 5 or 6 or 7 addresses, we can't keep changing the schema, right? We can't keep doing things like this, right? When does it stop? After 15? After 20 addresses? Okay. So this is just wasting space, and we're always having to change the schema, which is not a good thing. Okay. Let's look at option B. Instead of having to extend the schema, we're going to keep the schema the same. What are we going to do? We're going to repeat Jane Smith. Oh, so Jane Smith, first address. Okay. Jane Smith again. Okay, we're going to repeat Jane Smith. Jane Smith, new address. All right. And so if Jane Smith has 5 addresses, we're going to have 5 rows where the ID will be the same, the first name will be the same, the last name will be the same, and the only difference will be the address. Okay. Now, you might say this works fine. All right. We don't have to keep extending the schema, right? One address. Good. However, let's assume that Jane got married and Jane takes her husband's name, all right? She decides, you know what? I don't want to be known as Jane Suggs Nee Smith, all right? I just want to be known as Jane Suggs. Okay. So, oh, wait a minute. We're talking about marriage. Anyway, let's go back to the student. So let's say the student decides that the parent changes their name, right? So Jane will no longer be known as Smith. Jane will be known as Suggs, maybe taking her mother's name, right? Some falling out with her father, so she says she doesn't want her father's name anymore. So Jane Suggs. Okay. Now let's now say that we have Jane Suggs, this address. Jane Smith, this address. somebody, I think the principal, forgot to change this to Sugs too. And so let's say the principal retires and now there's a new principal, right? New employee. And so the employee will ask, is Jane Suggs or is Jane Smith? Are these two different people? Right? So the employee might say, well, I see one and one here, so I'm guessing they're the same person. But now I'm confused. Are they Suggs or are they Smith? Suggs, Smith, which one? Did I forget to update Smith to Suggs? Or did I forget to update Suggs to Smith? Because in the database, this is all you see. Right? That's all you will see. And so, if you are new and you don't know Jane, right? You've never met her, you will not meet her. So you ask, is it Suggs or the Smith? Did, did they make a mistake? Did they not update everything to Smith or did they not update everything to Suggs? We don't know. We don't know. So that's the problem with option B. Because you have the rows repeating, if you make a change or update one of them and you forget to update all of them, then you now have a database that is in an inconsistent state. The database, you cannot trust the database anymore to tell you the correct answer. All right? And so you can extend this to maybe you have some database that you decide you're going to do this approach and you end up with, let's say, 15 rows that are repeating. If you forget to change all 15, or if you want to change 12 and you skip some, that's a problem because now you will ask which one is correct. All right? You don't want that. So you say, well, okay, is there another option? Well, let's look at a third option, option C. You might say, well, you know what? Let's just put all the addresses into the address column. So I'm going to say address 1, comma, address 2, comma, address 3, and so on, right? And so you cram all the addresses into that one column, right? So you don't change address. You don't have address 1 or 2 or 3. Good. We don't have to change the schema. 2, we don't have the repeating names, right? So only one Jane Smith. Good. And then now we just comma, 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 comma. Now the problem with this is, how do I write a query to give me all the addresses? Because remember, SQL assumes tables have columns and each column has one piece of data. So what do I write? Okay, if we're lucky, when I write the query, it might give me back everything, right? Now, how do I deal with that? Right? Well, I could possibly dump it into a text file and then split it by commas, like what we do when we're copying the data from a file into Postgres, right? We say delimiter comma. And so we could somehow split up all these streets, all these addresses, and then somehow match them up to Jane Smith. Just talking about it, it's a lot of work. Okay, and what happens if you have somebody with not 2 addresses but 3? So it means you have to change the code that you use, which I just explained, to split up. Okay, and so it gets challenging. So this is what we call multi-valued columns, multiple values under one column. And so again, it avoids the earlier problems but introduces new problem, meaning it makes getting data out of the database, out of the table, difficult. It makes it really difficult because you have to do uh, uh, um, a lot of hacks, a lot of changing this and changing that and doing this and doing that just to get it to work. All right, that's what we call a hack. All right, and so we don't want to be fiddling and whatever with our code. We want it to be straightforward, right? So this is not a preferred option. Option C, it's not preferred. It just makes it hard when you have to process the data to get things from the table. It just makes it hard. And so that brings us to, right? So I'm asking, wow, how do I write a query to get the addresses? Not very easy. So that brings us to option D, which is the preferred option. So I want you to think of themes or topics, okay? And let's go back. Well, actually, we don't have to go back. Let's look at our table here, okay? We had the schema which created this table. We have ID, we have first name, we have last name, we have address 1, address 2, right? So this was the old schema. So think about it. If I were to ask you, what are the two things? Things means theme, or topics, right? What are the two things that this table is talking about, right? Or the schema is talking about. Let's go back to the schema. Where is it? Here, yeah. What is this schema talking about? What is it talking about? Well, things, right? Well, it's talking about student. That's one thing. Student bio, right? Student name. And it's also talking about addresses, right? So if you agree with me, those are two different things. They're talking about two things. They're related, sure, but they're different things. So we split the schema whereby we make a schema for each thing. So all I'm going to do, I'm going to say, okay, student will have ID, first name, last name. All right. And then addresses will have the name of the address, ID, of course, right? Because every table will need the primary key. And then I'm going to put this here. Okay. Why do I need this student ID? Simple. I want to have a way where I could link back the student and the address. So this student ID is my linker, is my linking. It allows me to see which student this address belongs to. Okay. So now all I have to do is to say, you know what? This is all this is all I need. Let me change this, right? So this is all I need. All right. Okay. Okay. So now in the students table, like I showed you in the schema, right? This is a schema. We have two schemas. Okay. ID, first name, last name. That's all I'm going to store. Okay. And then in this one, addresses or address, ID, name of the address, and who the address belongs to. Now, what does this solve? You might be saying, well, I now have two tables. Isn't one table better? Well, we looked at the one table and we saw the problems, right? So we split it into themes. So this is ID 1. Remember, no ID will repeat. So this is student 2. And so Jane, Smith, Jim, sorry, I never have to touch this table again unless I decide to change Jane. Let's say I change Jane to, what was Jane's name? Suggs. Okay, no problem. Done. Is there any confusion? No, because there's only one row for Jane. No inconsistency. Inconsistency. Okay, now for the address table, right? Each table will have the primary key, which never repeats, serial, 1, 2, 3, no problem. So address name, address name, address name. I see this one repeating. So this one simply means the student ID, which if you notice here, 1 means Jane Suggs. So this is Jane Suggs, this is Jane Suggs, and then 2, that's who's 2? Jim, sorry. So this address belongs to Jim, sorry. Okay, so it doesn't matter if a student has 10 addresses. All I will do is to say, put the first address, student 3, second address, student 3, third address, student 3, etc., etc. All right, and so the table remains consistent, right? I don't have to extend the schema. I don't have to do anything. All I have to do is put in a new entry. Now, I have separated both tables. So now your principal comes and says, can you please print a report for me? I want to see every student and their address or addresses. Okay. And so you would say, all right, I have two tables. I have multiple tables. I have information in both of them. And now I want to put that information together. Well, I write a join query. Okay. I write a join query. All right. So notice we can now store any number of addresses for a student without having to change our table structure or repeat student information or have multi-valued columns. Okay. And so I might just, create a little query that says, okay, give me the first name, S that first name. Give me the last name, S that last name. Give me the name or the address, A that name, from the students table, which I'm going to call S. And I want to join that with the addresses table, which I'm going to call A. And the way I'm going to join them is on ID and student ID. So I'm telling the DBMS, okay, DBMS, right, Postgres, I want you to look at this address table. And I want you to look at this student table. And I want you to check, okay? And I want you to see if you can find an ID in this table, and you can also find that same ID in this table, then it means it's a match. And once it's a match, I want you to return to me the first name, the last name, and the address or addresses. So in this case, since there are two matches, the database will return to me Jane Suggs, number 3 Apple Street, first row. Second row, it will also return to me Jane Suggs, Bird Avenue. Okay, and then it will say that's done. And so I will go down now and check. Okay, student ID is 2. DBMS will say, is there a 2 in the next table? Yeah, I found a 2. There's a match. And so the DBMS will return Jim, sorry, number 44 Jump Street. Okay, so we are putting back the two tables and making sure that we're doing it right. And the way we do it right is by matching up the keys. Excuse me, the key, right? So this is the primary key, right? This is the primary key. But these same keys are found in this table. Okay, in this table. So I'm going to throw out a terminology. This is a new term. Okay. Whenever we have the primary keys in another table, we now call them foreign keys. Okay, foreign keys. Okay, so in other words, when I'm doing my join, I want the foreign keys to match up with the primary keys, right? Because remember, in this original table, this is the primary key, right? And so in this table, they are now called foreign keys, right? And that's how you are able to bring the two tables back together. All right, so this is what we want to accomplish this week. I wanted to first explain a bit more why we are doing the splitting of the tables, and then that allows you to see why we have joins. The join command simply allows us to bring the table back together. All right. Okay, so in the next remaining videos for this lesson, we will go about implementing this problem and then writing the query to join the tables back so that we can get information. Okay, so I hope that made sense. So let's now write some code.